Hey there, and welcome. We're about to go on a really cool journey. We're going to uncover a secret code, the hidden language that powers literally everything you do on a computer.
Yep, we are about to crack open one of the biggest secrets in all of tech. I'm talking about the fundamental language that powers our entire digital world. It's going to be awesome.
I mean, really think about it for a second. How does a computer know how to show you a picture of a cat or let you play your favorite video game? We see all these amazing words and pictures and graphics, right? But what does the computer actually see? I can promise you, it's not a cute cat picture. Well, not at first anyway.
Okay, so to get to the bottom of this, we have to start with one simple fact. Computers, they don't speak our language. Nope, they've got their own special way of talking, and believe it or not, it's way, way simpler than you'd probably guess.
So look at it this way. On one hand, you've got us, right? We talk with thousands of words, we see the whole rainbow of colors, we have all these complex ideas. But how do computers talk? It's just ones and zeros. That is literally it. Every single thing a computer does, everything, boils down to a massive, long string of just those two little numbers. So, this secret code of ones and zeros, what's it actually called? It's time to put a name to this whole thing.
It's called binary. You see, we humans use what's called a decimal system. That's 10 digits, 0 through 9. But computers, they just use binary, which means only two, just 1 and 0. And this super simple system, this is the secret code running behind every single digital device you've ever used.
And if you break this code down to its smallest possible piece, you get something called a bit. That's just short for binary digit. A single bit is nothing more than a single 1 or a single 0. Think of it like this. It's the absolute smallest piece of computer information there is. It's kind of like the atom of the digital world.
Now, obviously, a single bit by itself can't hold a lot of information. So what do? They team up. A group of 8 bits gets together to make a byte, and a byte is just enough to represent something like a single letter of the alphabet, say the letter A. Then you get millions of bytes, and that's a megabyte. Billions of bytes, that's a gigabyte. So next time you see a file size on a game you're downloading, you'll know that number is just telling you how many billions of these tiny little bits are all working together.
And we are talking about a staggering number of them. It's just incredible. A single high-resolution video? That's not just a few bits. We're talking millions and millions, maybe even billions of these ones and zeros, all firing off in a perfect, super-fast sequence.
So the big question is, how can just two simple numbers do so much? Well, the easiest way to wrap your head around it is to imagine you're flipping millions and millions of tiny, tiny light switches. Okay, so inside the computer, a 1 basically means electricity is flowing through a tiny circuit. That's the switch being on. And a 0, that just means the electricity is stopped. The switch is off. On or off. That's really it. There are no other options. And because it's so simple, it makes it incredibly easy and super fast for a machine to understand what's going on.
But that raises a good question, doesn't it? If we can handle 10 different digits in our everyday lives, why can't our super powerful computers do the same thing? Why would they stick to just 2?
Well, it all comes down to two things: speed and simplicity. Think about it. If a computer had to figure out 10 different states for every single one of its billions of tiny switches, it would get really confused and slow way, way down. But by sticking to just those two simple states, on or off, it can process billions of commands every single second, and it almost never makes a mistake. It's just way more efficient.
All right, so we've got this code of ons and offs, of ones and zeros. I get it. But how in the world does that turn into the amazing, colorful pictures and videos we see on our screens every day?
Well, if you could zoom in, really, really close on your screen, you'd see that every single image is actually made up of millions of tiny little dots or squares of light. These little guys are called pixels, and they're the basic building blocks for every single picture you see on a screen. And this is where it all clicks into place. Remember that super long string of ones and zeros we were talking about? Well, that's basically just a giant set of instructions. A specific chunk of that binary code gets sent to each and every individual pixel on your screen, telling it exactly what color it needs to be and how bright it should be. And when millions of pixels all get their instructions at the exact same time, poof, there's your cat picture. Understanding this stuff isn't just a cool, fun fact. This secret code, it's the actual foundation for some of the most important jobs out there, and for the jobs of the future. So let's take cybersecurity, for example. The experts in that field are basically digital detectives.
They're searching through all that code, looking for a single 1 that was maybe changed to a 0. A tiny, tiny clue that could be a hacker's footprint. Or how about data science? Analysts use that exact same idea of telling pixels what color to be, but they use it to build helpful charts and dashboards. It's what makes huge, complicated amounts of information so easy for us to understand with just a quick look.
There's this quote that just says it all perfectly. It goes something like, just like atoms make up everything around us in the real world, everything in the digital world can be broken down into binary. And it's so true. Atoms are the building blocks of our physical world, right? Well, in the exact same way, binary bits, those simple little ones and zeros, are the building blocks of our entire digital world. From your text messages and photos to movies and games, everything.
And that kind of leaves us with a pretty fascinating thought to chew on. This incredibly simple on-off system, it has already allowed us to build these amazing virtual worlds, to connect the entire globe, and even create powerful AI. So if we can do all of that with just this beautifully simple foundation, it makes you wonder, what are we going to build next?